Okay. So in the previous class, we were talking about the communication protocols. In these communication protocols, we have seen the different types of communication protocols, and finally how the communication takes place between the users in the network, whether they are the okay. So the messages that get sent to the network in three different ways. So the message can be delivered in different ways in the network. Sometimes a person wants to communicate information to a single individual, or at other times the person may need to send information to a group of people at the same time, or even to all people in the same area. So the host on a network use the similar delivery option to communicate. So these methods of communication are called, the Unicast, Multicast, and your broadcast one. So what is there in the Unicast? If you see the first picture, in the Unicast one, you're finding there is a one-to-one delivery option is referred to as a unicast, meaning that there is only a single destination for a message. So if you see in the first one, then there are the users with the IP address 172.16.4.1, and another user is having the IP address 172.16.4.2. So here you can observe the first 3 bytes are same, right? 172.16.4 are same for all the clients in this network. So now the question is, if any IP address which starts with 172.16, is this IP address is a private IP address or public IP address? It's a private IP address. If any IP address series which starts with suppose 192.168.0.0, if anything starts with this, also treated as private IP address. So these private IP addresses are used in the private network, the local area network. And another series is 10.10.0.0. So other than this, if any IP address, if we have that 11.10.0.0, this is a public IP address. So other than these 3 series, if anything starts, they will treat it as your public IP address. So in unicast means there is a one-to-one delivery option. So if this user is the sender and this user is the destination or the receiver, suppose, then the packet goes through the switch and delivered to the only one user. If it is multicast means when a host needs to send message using a one-to-many delivery option, in that the sender can send these packets to a set of users, a group of users, or they may send to the every user in the network that called your broadcasting. That means any host in the network, they can deliver the message either one-to-one or one-to-many or one-to-all. Okay. So that is the different 3 different ways of communicating the information. We call that unicast, multicast, and broadcast. So by using this, what are the benefits of these communication protocols using the layered model? So if you recall the layered model, you can't actually watch the real packets travel across a real network. the way you can watch the components of a car being put together on a assembly line. But so it helps to have a way of thinking about a network so that you can imagine what is happening. A model is useful in these situations. So complex concepts such as how a network operates can be difficult to explain and understand. But for this reason, a layered model is used to modularize the operation of a network into the manageable layer. So these are the benefits of using a layered model to describe network protocols and their operations here. So assume assisting in protocol design, because the protocols that operate at a specific layer have different information that they act upon and define interface to the layers above and below of these layers part. If you take any network in this case. So the fostering competition, because products from different vendors can work together. So preventing technology or capability changes in one layer from different and from affecting the other layers above and below of those layers. It may be if you take the presentation layer, that affects its above layer as well as its below layer part. And this layered model that describes these network protocols to provide a common language to describe networking functions and their capabilities. So if you see in this diagram, there are two layered models that are used to describe the network operations basically. So you can see the open system interaction or interconnection reference model, or we can call it as your OSI model in this. So OSI model is consist of your 7 layers. One is your application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. And another, the reference model, the layered reference model is TCP/IP reference model. In TCP/IP reference model, you find there will be a 4, the layers are there in this TCP/IP protocol suite. So in this protocol suite, you will find the first upper layers, that is application layer, presentation layer, and session layer, they club together as the application layer only, and the transport layer is treated as your transport layer in the TCP/IP model, and the network layer is treated as your internet layer in TCP/IP suite, and your data link layer and physical layer together gives the network access layer. So in the OSI reference model, if you see in this model, in OSI reference model, the first part. So the OSI reference model that provides the extensive list of functions and services that can occur at each layer. It may be at your application layer, presentation layer, session layer, transport layer, network layer, your data link layer, and your physical layer. So it describes their services and their functionalities in OSI reference model. So this type of model that provides the consistency within all types of network protocols and services by describing what must be done at a particular layer, but not presenting how it should be accomplished. So it also describes the interaction of each layer with the layers directly above and below of these layers. So the TCP/IP protocol that discuss this protocol suite that we'll discuss in this course are structured around both the OSI and TCP/IP model. So you just assume that how these layers are clubbed together to minimize the consistency and description of each and every layer in this model. So in this case, if you see in this table, suppose in this table, if you see that it describes and gives the details about each layer of your OSI model, what it do. See the application layer that contains protocols used for process-to-process communication. Process-to-process communication. That means if sender is using, suppose, HTTP, then receiver must use the HTTP only. So if client is using, if client is using HTTP, server has to execute HTTP. If client is using, suppose, FTP protocol, server also use the FTP protocol. So here we say that there is a process-to-process communication. So whatever task done at client side, the same task will be executed at the server side. So directly we can say that the process-to-process means there is a virtual connection is there. And second one is the presentation layer that provides the representation of data that is transferred between application layer services. The representation. So if sender side is using the binary encoding, suppose, receiver side also execute the same binary decoding. Okay. And whereas your session layer that provides the services to the presentation layer, the above of this layer is presentation layer, so it provides service to its above layer as well as its below layer also. So this provides the service to the presentation layer to organize its dialogue and to manage data exchange. That means what? A session is established between your client and server. Suppose if that session may be your, the 5-minute session or your 1 hour session maximum, 1 hour session. So the session is established. After that time, the session is automatically goes down. And if the client and server still wants to communicate, they need to re-establish a new connection or new session. Okay. And the transport layer, it defines services to this segment. So whatever the PDUs comes from these layers through, those PDUs are divided into segments, and these segments transfer through the network devices, through the internet, and at the destination side, all these segments are reassembled the data for individual communication between the end devices. Whereas network layer is providing a service to exchange the individual piece of data over the network. So basically it establishes a path or your route between the end devices. So they try to establish a route from source to the destination. And then whereas your data link layer that describes the method for exchanging data frames, whereas in network layer the data over network is used the packets. A transport layer, it divides into segments. Okay, and at physical layer, this is the it describes the mechanical, electrical, functional and the procedural means to activate that and maintain a deactivate physical connection between bit transmission. So whatever the frames are there which are generated at the data link layer, they are further divided into bits, and bit streams will be exchanged between the devices. Right? So in TCP/IP protocol model, as we said, there are 4 layers will be there. So in these four layers, application layer that represents the data to the user, plus encoding and the dialog control will be there, will be handled by your application layer. Whereas transport layer that supports the communication between various devices across your diverse networks. Diverse networks means the internet service provider 1 to your ISP 2, it can transfer data from ISP 1 to your ISP 2. So different networks. And internet network or internet layer of your TCP/IP model that determines the best path through the network as said. It finds the path. And your network access that control the hardware devices like your Ethernet, your coaxial cables, twisted pair cables, fiber optics, copper cables, and the media that make up the networks. So this TCP/IP model simply describes the functions that occur at each layer of your protocol in this suite. So once, as we saw, there are different layers which use in practical. Generally, we use the TCP/IP suite. So every layer that provides service to its upper layer as well as its lower layer, or we can say above layer and down layer. So when the data is generated by a client, when the client is having a message or data, so that data, when it goes from application layer through your network access layer, the data goes through a particular operation we call the data encapsulation operation. So in this data encapsulation, what happens? It will first check the large stream of data which is sent across your network. It would result in delays. So instead of that, it simply processes that data into a small pieces, and those pieces we call them as the segments. So by knowing the OSI reference model and your TCP/IP protocol model will come in handy when you learn about how data is encapsulated as it moves across a network from through the different networks ISP1 to your ISP2. So it is not simple as the physical letter being sent through the email system. So in theory, a single communication such as your video or an email message with many large attachments that could be sent across a network from a source to a destination as one massive or the uninterrupted stream of bits. But however, this would create problems for other devices needing to use the same communication channel or links. So these large stream of the data would result in significant delays through the network. So further, if any link in the interconnected network infrastructure, if it is failed, suppose during the transmission, then the complete message would be lost and would have to be retransmitted again. In this case, so instead of that, whatever the message part is there, that message will be goes through certain operation we call. So the better approach is to divide this entire the data or entire message into a smaller or more manageable piece to send over the networks. So if any piece of the message goes during the transmission if lost, so it is easy to send the same piece of information, so that on server side they can rearrange all these piece of information, reassemble, and they can generate the original message. So this concept gives that by sending this manageable piece to over the network, the segmentation is the process of dividing the stream of data into the smaller units for transmission over the network. So this segmentation is necessary because the data network use the TCP/IP protocol suite to send the data in the individual IP packets. So each packet is sent separately and similar to sending a long letter as a series of individual the postcards. So the packets containing the segments for the same destination can be sent over the different path. So if the message is divided into suppose three pieces, let us assume in that piece 1, your piece 2 and your piece 3, and if there are the different paths are existing suppose, then the piece 1 can send through one path, piece 2 can send through another path, and piece 3 can send through another path to the destination side. So while when this piece of information received by this destination, they can arrange these pieces in the same sequence to generate the original message 1, 2, and 3 to generate the original message. So in this case, what is the advantage that we are saying? During this transmission, let us assume that this piece is not received. During the transmission, if it is lost, then it will not reach received by your server. I mean the destination side. Then for this message, there is no acknowledgement, or the negative acknowledgement will be sent back to your sender, so that only that piece will be resent. So that piece may go through another path while it is transferring to the different means when retransmission do. So with that, what happens, instead of sending the entire message through the network, only a piece of message is sending. That means it uses less bandwidth. So the network performance will be increased in such way. That is so this concept basically leads to increase the speed of your network, because a large data stream is segmented into packets and large amount of data can be sent over the different paths or different network without tying up a communication link or dedicated communication link between your sender and receiver. Without dedication link, they can use the multiple paths which existed between. So and it also increase the efficiency of your network in this case, right? So that is the advantage of each packet which sent separately and the packets containing the segments for the same destination that can be sent over the different paths. So that is the segmenting the messages. So when you are segmenting the messages, every message should be identified, right? So how it will be identified then? So as we saw, the benefits of this segmentation, one is your increase your speed and the efficiency. But doing this, the sequencing, when you are dividing the message into small parts like 1, 2, 3 and going through different paths, then the sequence number should be given to them. Because all these messages which are received by your server, it must rearrange all those piece of segments to generate the original message. So that is depends upon the sequence number. Yes, please. Pardon? Yes, they can arrive out of order. Because if one path may be the shorter path, one path may be the longer path. So they can arrive in out of order, but when they receive, when all the packets are received, then it is the job of server or the destination to rearrange them. Okay. So as said, while transmitting the messages using segments and use the multiplexing that one, so there is a possibility of data to reach the destination in a collapsed order, as said. So then they must be rearranged. So the TCP is responsible for sequencing the individual segments. So TCP is responsible for doing the individual segments, means the data decapsulation and data encapsulation done by which layer of your TCP/IP model? Is it application layer or the transport? Because TCP protocol provides service for its upper layer. The upper layer is application layer. So at application layer, you are having the protocol data unit. So that data unit is divided into pieces by the transport layer. So when transport layer is dividing, it is the responsibility of transport layer to give sequence for each piece of individual. Okay. Yeah. So at the application layer, if you see the protocol data units, we also called it as your PDU, protocol data unit. So as the application layer data is passed down to the protocol stack and its way to transmitted across the network media, so various protocol information is added at each level. So this is known as the encapsulation process. So the form that a piece of data takes at any layer is called the protocol data unit. But the different names are given for different layers to easily identify. If you heard the terminology that that piece of data is termed with the segment, means that piece of data handled by whom? Transport layer. If you heard the piece of data termed with packet, means that is handled by your internet layer. If you heard the piece of data with frames, that means it is handled by data link layer or network access layer in TCP/IP. Okay. So in the data encapsulation process, if sender is having a email data, suppose this email data is divided into small pieces. We call data 1, data 2, data 3, the entire data. Okay. And this entire data is piece by piece, it will go through the next layers. So from up in the application layer, it is the email data. So when it is divided by your transport layer, then for that individual data, the transport layer header is added to that data field. Okay, for this piece. Similarly for this piece. Similarly for this piece. Okay, so for every piece of data, the next layer is your transport layer. Transport layer header is added to the data. Then when this segment, we call this as your segment. So the data plus the header field of next, that is transport layer, is known as segment. Okay, next. So this segment pass on to the next layer on sender side. This is on sender side. Okay. When it pass down to the next layer, then this segment is again encapsulated with the header field of the next layer, that is your network layer header, will be added to the segment. Then the network layer header, transport layer header, and data, which is called as your packet. Okay. And then when it is passed down to the next layer, there it will add the frame header. It will add the frame header, or we call the data link layer header. So then data link layer header or frame header, your network header, transport header, plus your data, we call this as your frames or medium dependent. It is medium dependent means if it is using twisted pair cable, then these frames will be generated based on twisted pair cable characteristics. If it is transferring through the coaxial cable, suppose, so these frames will generate based on coaxial cable. But here the important is when the packets are converted into your frames, there will be a frame header and frame trailer to separate this frame from other piece of data or from other what you call the packets or segments or data unit. And once these frames are done, then from there it goes to the physical layer. Physical layer means this data will goes pass or send through your medium. We call it, the copper wire, twisted pair, anything. They can just carry the electric signals. So electric signals are in the form of your zeros and ones, on off, on off. So that frame is converted into bit streams. So now these bit streams go through the cable which is we are using here, go through this cable and go through the network devices and reach, go through the internet and reach to the destination side. If destination is having another computer here, so it reach to the destination side. Right? So if the transport header is TCP, then it is a segment as said, and if the transport header is UDP, then it is called a datagram. It must be clear. Why? Because if transport header is TCP means it is a connection oriented network or connection we can say. That means before sending this email, the connection will be established between your source and destination first, and after that this email goes through these layers by layer for a data encapsulation and reach. If it is UDP, suppose user datagram protocol, we called it as your datagram simply. We don't call it as your segment. So in this case, whenever the data is ready at the sender side, whatever the possible outputs are there, this data is simply injected into the network, and it is that UDP is having only the source IP address, destination IP address. There is no route, so it can go through any route and reach to the destination. So in TCP connection, there is a reliability because the path is already established, so always go through that path. All the data goes through the same path. Whereas in UDP, the data pieces which we have seen, this piece 1, piece 2, piece 3, they may go through different routes and reach to the destination. But whereas in TCP, all these goes sequentially one by one, first piece 1, piece 2, piece 3, through the same path. Okay, so that is the segment means transport layer PDU, protocol data unit, and data means it is your application layer PDU, packet means network layer, frame means data link layer, bits means your physical layer. So this is very important to remember. So if you heard the term that bits in the network, that means it is belongs to your physical layer. If you heard that packets, means it belongs to network layer. If you heard that data, means application layer, data unit. If you heard, if you coin that frame, that means it is a physical layer. Sorry, it's the data link layer. Okay, so in this data encapsulation, the three addresses are the most important one. One is the network protocols, the network layer protocol that requires addresses to be used for network communication. What are those? The OSI, transport, network, and data link layer. Transport layer, network layer, and data link layer. They use the addressing in some form. Okay, that means the lower three layers, the lower layers, they use the addressing. Okay, so the upper layers we call them as your application layers. Lower layers we call them network operated layers. So in this what happens? So when network operated means they need to identify the devices in the network. How to identify? They must have an address. So in the transport layer that uses the protocol addresses in the form of port numbers. So when we talked about the port numbers, if you recall that, we use the port number 2021, port number 20, 223, port number 443. So these port numbers are numbers are the addresses. These addresses are belongs to a layer of your TCP/IP model. That layer is your transport layer, right? And the network layer they use is they specifies the addresses that identify the network that client and server are attached. We call them as your IP addresses, Internet Protocol addresses. So IP version 4 or IP version 6 will be used. Then the data link layer that specifies the devices on the local area network in the private network that should handle these data frames. We call them as it uses the address MAC address or physical address, we say. Okay. So all these three addresses, your transport layer address, network layer address, and your data link layer address, all these three addresses are required for client server communication to identify client and to identify servers. Right? So here from application, we say application layer from sender side and your receiver side, they are the virtually we call the process to process communication. Even presentation layer also, even your session layer also. But whereas the lower layers, they are connected with point to point network. Point to point network. Okay. So here in the encapsulation process, if you see, when a message is being sent on a network, the encapsulation process works from top to bottom, from sender side. On receiver side, it is bottom to top. So at every stage, the decapsulation will be done. So first, when bit streams are received, then bit streams will be converted into your frames. Then those from that frame header and frame trailer will be decapsulated. Then it forward to the next layer, that is the network layer. When it goes to network layer decapsulate the header field of network. So then it goes to the next layer, that is your transport layer. Transport layer decapsulate the transport layer header. Then it gives to your application layer. So in that application layer, whatever the form of data is there on sender side, same form of data will be appears to the receiver. So here, what is the use of data encapsulation and decapsulation? Because when the data is going through the network, it may go through different network devices and it may reach to different end devices. So by checking the header field whether that message piece or data piece belongs to them or not. If belongs to them, they decapsulate it. If not belongs to them, they forward to the next. So that's the use of that one. So at each layer, the upper layer information is considered the data within the data encapsulation protocol. Right? So then you can see here in this example, in the decapsulation, upon receiving the bit stream, it will first decapsulate the user's data in such a way from Ethernet frame, it decapsulates the frame segment. Then you will get the IP packets. From IP packet, Internet header field is decapsulated, so TCP segment will be there. TCP header field will be decapsulated, then user data will be available to the receiver side. So this is data encapsulation and data decapsulation. Okay. Let me just play a video for you for better understanding. Mm. You can see from web server, whatever data is there, that data is the user data first, right? So then that data is encapsulated with TCP on sender side. And then that data will be encapsulated with the network layer to generate packets. So then that will be encapsulated with the physical layer, that is Ethernet layer, and that will convert into your bit streams, and bit streams will go through your cable and reach to your web client, right? So this is on sender side, and same thing, on receiver side. If you find on the receiver side here, it will give you the details. You can see as soon as it's received by the client, the decapsulation process takes. So first Ethernet will be go, then IP frame, then your TCP header, and finally the user data will be available to the client for the request. So I hope it's clear for data encapsulation and data decapsulation. Good. Okay. So then you see this in the lab. You will use this Wireshark to analyze the software. It is a software protocol analyzer. So this is, or we also call this as your Wireshark as your packet sniffer application, which is used to network troubleshooting, analysis, software and protocol, which is developed the education purpose. So you use this Wireshark to capture and analyze the network traffic. So there you can find what is the source address, what is the destination address, what is the TCP header feed is there, that you can find in this case, right? So then in this network protocol summary, if you find, you can say that what we discussed, what are the different sizes of networks are there that we have discussed, the size of your networks. So then we checked what are the servers or the host that utilize the specialized software, and there will be clients. So the softwares will be installed on the client for communicating client-server communication purpose. And then we have checked that how these client and server host that use the software application for different purpose, like for web browsing purpose, email or file transfer. So different application protocols are there. And then how they are connected to each other means by using your internet service providers, so using cables. And then the network protocols that specifies the feature of your network communication, such as message encoding and message formatting, encapsulation and decapsulation process. And finally, the protocol specifies the messages are structured and the way the network devices share the information through the pathway. Right? And then we have seen the common protocols of your TCP/IP suite. What is the DNS, DSCP, POP, and HTTP belongs to your application layer. And in TCP/IP, they use the TCP and UDP protocols. And at the data link layer, at the network layer, they use the IP routing or the routing protocols. And at your what you call the data link layer, it uses the frames. or and physical layer it use the Ethernet cabling. So these are the basic network protocols which used in this in the network for exchanging the messages or transferring the information. So the next one we tried to find. So as we said, every layer is using the addresses. So now you tell me the TCP